So let's jump right into it. So from here, we're on constants, variables, and data types. This is page 20. Alright, so building apps and programming in general is all about working with data. As a developer, you'll need to understand how to handle and store data using clearly defined types. In this lesson, you'll learn how constants and variables enable you to name pieces of data so they can be used later in your program. You'll learn to define constants for values that don't change and to define variables for values that do change. You'll also learn about types, which are like blueprints for working with data. Different types can be used and stored in constants or variables. You learn what types are included in Swift and how Swift types can help you write better code. Here's what you'll learn: how to represent numbers, strings, and Boolean values using native Swift data types, when to use a constant and when to use variable, how to assign values to constants and variables, how type inference helps you write clean code, how type safety helps you write safe code. Alright, here's some vocabulary for us. A bool. A Boolean, or bool, type has only two possible values, true and false. Booleans are named after George Boole, a 19th century mathematician who realized how important it is to ask clear questions with simple answers. That's pretty cool, didn't know that. Alright, Mr. George Boole, thank you for the word. Constant. A constant is an immutable identifier. Once a constant is assigned a value, the value can never change. Alright, comment. Alright, and we know that a comment is just something for developers to kind of use in order to make their code more readable. So if you're reading a section of code, you have kind of like a comment in your code to help, you know, someone else looking at it understand what the purpose of that code is in context. So, you know, just kind of like a note for someone else looking at your code, and also for yourself if you come back to it at some point. Alright, then we got a double. A double is a number with a decimal point like 7.78 or 1000.0. If you initialize a constant or a variable in a Swift to a literal number with a decimal point like let distance equal 26.2, the type is inferred to be a double. So you don't even have to say it's a double, because automatically Swift knows that since it has a .2, it is a double. Very cool. Right, a function. A function combines lines of code into a single block that can be used again. Some functions have inputs and change their behavior based on arguments from their caller. Some functions have outputs and give a result, and some functions have neither. Alright. Immutable. An immutable object cannot be updated or changed. A constant is immutable. A variable is immutable. Int. An int stores an integer or whole number such as 10 or -42. Let. Let allows you to store a value in a named constant. The value of a constant doesn't need to be known at compile time, but you must assign it a value once and only once. Mutable. A mutable object can be updated or changed. A variable is mutable. A constant is not. A little bit of repetition there, but you know, repetition just helps you memorize stuff. A property is a piece of data held by a structure, class, or enumeration. For example, each array instance has a count property that differs depending on the characteristic of the array. Type inference. Swift uses type inference to work out an object's type from the available information. Even when the name of the type isn't explicitly put into words in code, for example, if a function is declared to return a string like func answer string and a constant is initialized with the answer, functions result like let next idea equal answer, the type of next idea will be inferred to be a string. Very interesting. Type safety. Swift has type safety to prevent writing code that uses types incorrectly or unexpectedly. For example, if a function expects a type fruit and you try to call it with vegetable, your app or playground won't run until you fix the error. Variable. A variable represents a value that can be changed after it's been initialized, indicated in Swift by the word var, by the var keyword. And var allows you to set a variable. All right, let's go to the next page here. Okay, constants and variables associate a name like age, or name with a value of particular type, like the number 29 or the string John. You can use the name to refer to the value many times in your program. Once it's set, the value of a constant is immutable, which means that it cannot be changed. In contrast, the value of a variable is mutable, which means that it can be changed at any time. By defining a constant or variable, you're asking the compiler to allocate storage for the value in memory on the device that will run the program. You're also asking it to associate the constant or variable name with the assigned value so you can access the value later. Alright, constants. When you want to name a value that won't change during the lifetime of the program, you'll use a constant. You define constants in Swift using the let keyword. Alright, so let name equal John. You know what, let's follow along here with Xcode. Let's get started with the playground. My playground, create. Alright. You know, this code is this font is just a little beefy for my liking. I'm just going to bring this down just a little bit. Still huge. You know, let's do basic and see if we can bring up the text here just a little bit. Okay. 1 second. You know what? Let's see, default. Raise it all up just by a little bit, like right around there. Yeah, I like how that looks, because if it's too big, it's not really readable. If it's too small, it kind of defeats the purpose for us. Then we can't kind of look at the code together. All right. Let's make this a little bit larger, and let's go for it. We can actually leave that code there because it's not in the way. Let's see what we've got here. We're going to say let name equal John. Okay, the code above creates a new constant called name and assigns the value John to the constant. If you want to access the value in later lines of code, you can use name to reference the constant directly. This quick reference is especially helpful when you have one value that you use many times in a program. Let name equal to John. So let's see. If we do print name, let's see what we get here. Why is this not showing up? There we go. John. Awesome. So you can see it here in the console, and in this kind of basic sidebar here, it prints John just fine. Alright, so that makes sense to us. Let's continue. This code would print John to the console because name is a constant. You can't give it a new value after assigning it. For example, the following code won't compile. Let name equal to John. Name equals to James. We can't change it. If it was var, we could change it. That makes sense. Okay. Next page. When you want to name a value that may change during the lifetime of the app, you'll use variable. You define variables using the var keyword. Okay, so we're going to do var. We're going to do var age equals to 29. And now if we go to print see if we get that in the console. Oh, how about you spell print right instead of pring? Maybe I'm in the mood for Pringles. All right, print age. And we got 29. Very cool. All right, now the code above would print 29 like it did. Because age is a variable, you can assign a new value in later lines of code. The following code compiles with no errors. All right, let's try that. Age equals to 30. Okay, and we're going to do print age. And see the result in the console. And age did print 30. Awesome. Alrighty, so this code would print 30 in the console. You can assign constants and variables from other constants and variables. This functionality is useful when you want to copy a value to one or more other variables. So for instance, let default score equal 100 var player 1 score equals to default score, and then var player 2 score equals default score. So here they're essentially just letting us know that we can pull a constant and use it as a variable. So essentially we're taking the let constant of default score, which is 100, to be assigned as a variable to player 1 score and player 2 score. So that's an interesting kind of piece of code, and it may come in handy at some point when you're writing a specific kind of app that needs to pull a constant value and use it as a variable. And then if we put that into concept, we can say player 1 score. We can do print player 2 score. Let's see what we get. Yep, they both come up as 100 in the console here. Alright, that's great. Let's see if we can do this. We can change player 1 score and make it equal to 200. And we can do print. Try to type stuff too fast sometimes, and I can do it. Print player 1 score. See what we get there. What's not happening? Player 1 score, player. Something's not happy here. Player 1 score. So I have a typo somewhere, so let's see where it's at. Var player 1 score. You see that? I wrote player 1's score. Then something like that can take you frickin' 6 days to figure out, and it's one damn typo, which is kind of like, you know, type a little bit slower and you won't run into these problems. And there we go, it printed to 200. So it's, you know, something like this where we're just doing a basic thing. You do a typo and you're kind of reading over it quickly. You don't even see, you know, the small error that you made. All right, let's continue. Constant or variable? All right, let's see. All right, so you just learned to use a constant when the value won't change and a variable when the value might change. But there's a nuance here that's worth learning. Even though certain values might be variable, you can represent them with a constant because they won't change during the lifetime of a single execution of the code. Imagine you're calculating information about the distance traveled on a trip. The program can be reused to track many trips over time, but it tracks one trip at a time. How would you represent the following data in your code? So starting location, this is a GPS coordinate of where you started your trip. Once you begin tracking a trip in your program, the location won't change. You'll represent this value with a constant. Yes, because if we start on, Strawberry Hill Lane, that's always going to be the starting point in this instance of code. So like during this trip essentially. Destination. This GPS coordinate is where you want to arrive. Your app can be used for many destinations, so you may think this would be represented with a variable. But once your program begins tracking a trip, the destination won't change. You'll represent this value with a constant. Makes sense. So our destination is always going to be the same unless we quit the app or quit the trip, which means that the code would restart. So essentially, it's still constant during that execution of the code. Okay, current location. The GPS coordinate of your current location will change whenever you move, so you'll represent this value with a variable. Makes sense. While you're driving, you want your tracking to be, you want the sort of icon tracking your location to be consistently updating with your GPS coordinates. All right, current location, we just did that. Distance traveled. Okay, how far have you traveled from your starting point? This value changes as you move, and obviously it's represented with a variable. Distance traveled, how far you've traveled from your starting point. This value changes as you move, and once again we have another variable. And remaining distance, how far must you travel to arrive at your destination? Excuse me. The remaining distance changes as you move. You'll represent this value with a variable. Constants and variables perform very similar jobs. You may think it would be easier to use variables for everything and ignore constants altogether. Technically, your code would work, so why should you use constants at all? Good question. Okay, first, if you set a value to a constant, the computer understands that it should never be changed. This means you won't be able to build or run your program if you try to change the constant's value. In this way, the compiler enforces safety. Second, there are special optimizations that the compiler can make for constant values. When you use constants for values that won't change, the compiler can make low-level assumptions about how to store the value. These adjustments allow your program to execute faster. Third, it is the idiomatic or correct way to do things in Swift. Alright, as you learn more about building software, you'll come to appreciate best practices for consistently writing clean, reliable code. This is especially important when working on a team with other developers. You'll also discover that following best practices will make it easier for you to remember what your code does, especially when you want to make changes later on. Okay. If you want to be a great developer, you'll need to follow shared patterns and conventions. This course will guide you toward the best practices for writing Swift. Naming constants and variables. There are rules for naming constants or variables. The compiler enforces these rules, so you won't be able to build and run a program if you break them. Names can't contain mathematical symbols. Names can't contain spaces. Names can't begin with a number. Okay, other than these three rules, you can name a constant or variable whatever you like. Alright, so you'll notice here that they have pi here. When they said you can't use mathematical symbols, they didn't mean pi. What they meant is things like operators, so plus, minus, equals, that kind of thing, division, multiplication. Alright, so let's try to make one like emoji one just for argument's sake. I always forget how to make the emojis come up. I wish I could remember. I think it's Option Command Space. No. No. How about Control Option Space? I'll never remember how to do that. How do you pull up the... How do you pull up the emoji viewer? Come on. Alright, we're gonna have to Google that. Sidetrack. Emoji on Mac. There's a keyboard shortcut. Alright, OS 10 Daily. Let's see what they have here. Come on, give me the keyboard shortcut. Command Control Spacebar. I thought that's what I did. Command Control Spacebar. I could have swore I did that. I don't know why I didn't pop up last time. But alright, so let's say let this check mark equal a string, which is going to be good job. Alright. So let's see if we can do print. And let's see if it prints out good job. And we got another error. Why did we get this error? What does it like here? So what if we do let good job equal to okay, so as it turns out, an emoji cannot be set to be a string, which doesn't make much sense. So let's see if we can make that work again. I don't agree with that. Let this emoji equal good job. I want the emoji to be a string. Print this emoji. Interesting. Alright, so fun fact, looks like you can't, or at least in this example, for whatever reason, Playground, what's the error? It won't even tell me what the error is. Expected pattern. Alright, yeah, so for whatever reason, you can't set that. Maybe we can, what if we make it a variable? See if it'll print it now. Nope, doesn't matter. Alright, so we can set the result of an emoji, but we can't do that. So what if, okay, so maybe we can set it to a number. Let's see. What if we set it to a number? See if it'll print it now. No. Does not care. So we can't do a print command with this. Apparently you can set this emoji to equal to 7, like you have this dice equaling to 6. You can't, even though it's in theory set to be 7, you can't print it to the console. So yeah, that's pretty interesting. That's pretty interesting. Very interesting. Alright, so let's carry on then. Alright, in addition to the rules, these are some best practices for naming constants and variables. Constant and variable names should be clear and descriptive, making it easy to understand the code when you come back to it later. For example, first name is better than N, and a restaurant near current city is better than nearby. To be clear and descriptive, you'll often want to use multiple words in a name. When you put two or more words together, the convention is to use camel case. Okay, so camel case essentially means first letter of the word is lowercase, the second letter in the phrase is uppercase. Okay, and that's just what I said. Okay, default score is the same camel case treatment of the combination. Camel case is easier to read than all the words mushed together. For example, default score is clearer than default score. So over here there is all lowercase, and over here of course we've got camel case with the uppercase S for the score. And restaurants near current city is cleaner than restaurants near current city. Obviously it's easier for the eyes to differentiate with uppercase letters dropped in between each word. Did you notice that the translation for the Ansatzbruchberdücker, that's a little bit of German, there was written off to the side? As code becomes more complex, it can be useful to leave little notes for yourself as well as other developers who might read your code. These comments are created by placing 2 forward slashes in front of the next. We remember that from reading our vocabulary words in the beginning. When your code is compiled, the comments will be ignored, so write as many as you find helpful. So let's write some comments here. The emoji cannot be printed to console. Cannot be used to set a constant and then have that constant printed to console. In this example here, we see that even though we have set it, it will not print it. Alrighty, okay, let's get rid of that. Excellent. At least we know that we're all on the same page. And now if you have a lot of code, see, like I had to type a lot of code out. One thing you can do is do // asterisk, and then at the end of your entire code, asterisk /. And then you can, type in between, and everything in between will be commented out. Very cool. You can see. All right, let pi equal 3.15, because in my world I like 15 and not 14. Let's see if we can do print. Alright, we got 3.15. Very cool. Okay, let's move on to the next page. 26. Comments are most frequently used to explain difficult sections of code, provided copyright information at the top of a file, and to provide dating information when the file was created and or modified. Each Swift type comes with properties and functions that may be helpful when working with constants or variables of that type. A property represents the information about an object, and a function performs some sort of action with the object. Consider a simple person type defined below. So struct person All right, and then we got let first name be a string, let last name be a string. See, instead of equal signs here, we're using these colons, and these colons are just defining that both of the last and first name are strings. So even though if you type a number, handle that number as if it was a text. So now we're creating a function, and this function is say hello, and then we go print hello there, my name is / and 2 forward slashes, and then in front of the forward slashes we have first name, which is our constant, and last name, which is our constant. Alright, very interesting. Let's try to write that out. Struct person, and then if you hit return, it'll automatically give you another curly brace, let first name, and we're using camel case, remember that. It's going to be a string, and then we're going to do let last name also be a string. Okay, now we're going to do function, which we're going to make say hello. Open another curly brace, and then hit return, and it'll close the curly brace for you. We're going to hit print. Okay, and within the print, we're going to say hello there. My name is, then we're going to do a backslash. And we're doing this backslash with the parentheses so that Xcode or Swift knows that I want you to pull this information now from the constants that I created earlier. Then we're going to do a little space, we're going to do another backslash, and we're going to put in last name. Oops. Swift, cut the bullshit. Last name, there we go. We can do a period at the end of that. That's ready for us. Excellent. Alright, you probably aren't familiar with all the syntax in the code block above. That's okay. It's called a type definition, and it defines the properties and functions of a person type. You can think about a type definition as a blueprint for how objects should look and function. This example describes how objects of the type person should look and perform. By reading it, you can see there are 2 string values, first name and last name. These are called properties, which store information about the person. You also see say hello, which is a function, and it defines an action for the person. Okay. Whenever you create a new variable, you're creating an instance of a type. Consider the following code. Let a person equal person first name job, comma, last name Edwards. Let another person equal to Candace, last name Salinas. Okay, so now let's see if our code will work. Let's see if we can use our previously created function and object to execute some code here. So let a person, we're setting a constant here, person, first name, and then notice how we're using the colon here. Jacob, comma, last name, Edwards, again we're going to do another constant, another person, equal to person. Oops. First name. Candace. I think Candace is a nice name. Like Casey Neistat's girlfriend, or wife rather. No longer a girlfriend. Last name. Colon. Salinas. Okay, and then we're going to close bracket. And now we can do a person dot say hello. Hello there, my name is Jacob Edwards. Alright, we got that printed out to the console, which you can see down here on the bottom. Let's see if we can do the second one now. And the second one we created was another person dot say hello. Then another person dot say hello is. Did I spell something wrong? Yes, I did. I spelled person wrong. It's getting late at night and I'm beginning to get sleepy and not being careful with what I'm typing. And then, hello, my name is Candace Salinas. So definitely a great beginning to actually getting some code to function and using objects and different constants and pulling them all together to give you a final result. So you could also do, you can create another let and let it be person 3, person 4, person 5, person 6, and you can kind of see where these would kind of come into play. If you were maybe creating like a like a storyline in a video game or something, this kind of method with functions would definitely come in handy. All right. Let's go on to the next page. Or before that, let's read this. This code creates 2 instances of the person type. One, the instance represents a person named Jacob Edwards, and the other instance represents a person named Candace Salinas. And we can tell, so basically a type, the word that they use here for type is struct. They don't give enough emphasis on that, but when you're typing struct, and then you write person, you could have written car here, it doesn't matter what you write, but the point is that when you write struct, within that struct you're defining kind of a type, so you should kind of be aware of that. Swift comes with many predefined types that make it easier to write clean code. Whether your program needs to include numbers, strings, or booleans or boolean values, you can use types to represent a specific kind of information. Okay. Alright, here are a few of the most common types in Swift. Type name, integer, int, double, boolean, bool, string represents text. Yes, we kind of got all that because we've done all this. Swift also supports collection types, which group instances into a single variable. One collection type is called an array, which stores an ordered list of objects. Another collection type is called a dictionary, which has keys that help you look up specific values. You can use collections to store multiple objects in a single constant or variable. You'll learn more about collections in a future lesson. The Swift standard library includes all of the types above, so they're always available to you. In addition, you can define your own types in Swift using the same structure you saw earlier in the person example. You can define your own types in Swift using the same structure you saw earlier in the person example, which is interesting. They're using the word structure, and then we have, it's initiated with the word struct, or the keyword struct, but it's actually a type. You can define your own types in Swift. So see, it all comes kind of together, but it can be blurry for you if you're not paying super close attention and kind of looking for these kind of keywords here. So struct, structure, types. It's kind of a good way to remember that. So essentially, that's, in the beginning, this is all going to be kind of blurry, no matter what you do. All right, type safety. Swift is considered a type-safe language. Type-safe languages encourage or require you to be clear about the types or values your code can work with. For example, if part of your code expects an int, you can't pass it a double or a string. When compiling your code, Swift performs type checks on all of your constants and variables and flags any mismatched types as errors. If you mismatch types, you won't be able to run your program. So a good example of this would be you shouldn't use a double while trying to get a date, because you can't have the 14th.7 of April. Dates are integers. All right, let's continue. Let player Julian. Let player name equal Julian. Let we got var player score equals to 1000. Var game over equals to false. All right, player score equals to player name will be a flagged or missed. Will be flagged for mismatched types. Will not compile. Player score equals to player name. The player score can't equal to player name because player name is a string and player score is an integer. Okay, because type safety requires you to be careful about which types you work with, the example above is an obvious mismatch. Assigning a string value to an int variable doesn't make sense. When you access player score, you know you want a score value represented by a number and not by text. Type safety also applies to values that represent data that may seem compatible. For example, the compiler recognizes int and double as completely different types, even though they both represent numbers. So var whole number equals to 30, var number with decimals equals to 17.5. Whole number equals to number with decimals. It will be flagged as a mismatch because you shouldn't equal a double to be a int. In the case above, both variables are numbers, but whole number will be an int and number of decimals will be a double. In Swift, you can't assign a value of one type to a variable of another type. When working with numbers, you may find that you need to assign a very large value to a variable or constant. This can be difficult to read, since it is hard to see how many zeros there are in whatever this is. I think this is 10 million or 100 million. Fortunately, Swift allows you to put underscores in your numbers as a way of formatting for easier reading. Very cool. So then you obviously know that this is 1 million. And otherwise you would have not been able to do this, because that would have been a syntax error in other programming languages. So very nice that Swift allows you to place underscores without the compiler giving an error. Type inference. You may have noticed that you don't have to specify the type of value when you declare a constant or variable. This is called type inference. Swift uses type inference to make assumptions about the type based on the value assigned to the constant or variable. Let city name equal to San Francisco. So San Francisco is obviously a string because it's text. So the compiler automatically assigns a type of city name to a string. Let pi equal to 3.145 is obviously going to be a double because it automatically understands that. So which is pretty awesome that it does that without having to tell you, without you having to tell it. So let pi, string or whatever. So that's pretty awesome. Once you assign a value to a constant or variable, the type is set and can't be changed. This is true even for variables. The value of a variable may change, but not its type. There may be cases when it's useful or even required to explicitly specify the type of a constant or variable. This is called a type annotation. To specify a type, add a colon. Very good to know. So if you want to specify a type, add a colon, a space, and type the following, and type the name following the constant or variable name. So let's give that a go here. All right, so we're going to do let city name Okay, we're telling the compiler now string. I don't want you making assumptions for me. I am telling you specifically that I want San Francisco to be a string. Okay, now it would have made the assumption correctly for us anyway, but there are some times where we may have not wanted it to make that assumption. Let pi double equal to 3.145. Oh my gosh. Okay. Very cool. Okay, you can use a type annotation with different number types. The Swift compiler will adjust the value to match the type. Let number double equal 3. And okay, and then we're going to do print number. Oops, lowercase. And it adds the 0.0 at the end because it will be assigned the type to be a double. So in this scenario is kind of an example of where you would actually want to specify the type that you're going to be using. So very good to know that. Okay, let's go to the next page. Alright, there are 3 common cases for using type annotation when you create a constant or a variable but haven't yet assigned it a value. So, let's see. Alright, we're going to do let first name. Before we do that, I'm just going to comment out all that code that's above so it doesn't affect us. Asterisk backslash. We're going to do another one, asterisk forward slash. There's an asterisk backslash. Oops. Asterisk backslash. Asterisk forward slash. No? Not happy? Forward slash asterisk. There we go. Forward slash asterisk, asterisk, backslash. Okay, very good. Let us continue. Oh no, that's not what we wanted. See, this is confusing the shit out of me. Forward slash. So let's do backslash, asterisk now. Jesus. Okay, so forward slash asterisk. Backslash asterisk. No, still not doing what we want. Why is it still doing? Okay, so this is where we're going to have to go back. Because we're on page 31, we're going to have to come back to 31 and see why. Comments. Comments. Let's see if we can find what it wants here. Comment. So it's forward slash asterisk asterisk backslash. Okay. This is very important to remember because this is going to confuse the shit out of you one day and you're not going to know why the hell your goddamn comments aren't working the way they're supposed to. So let's take a screenshot of this. Okay. add a note, just so that that stays with us. Alright, now let's try this again. We want to comment out all of this. So it's going to be / asterisk. And if you go to the bottom, it's going to be asterisk /. And now everything below it is code again. There we go. Alright, let's move on to the page that we were on. Let's close this, and continue. Okay, so let's see. Let first name be a string. Okay, and then we're just going to do a comment here. This is just for argument's sake. And now first name equals to Lane. I don't like that name, but that's fine. Okay. When you create a constant or a variable that could be inferred as more than one type. Okay, let's see. Let middle initial character equal J. So J would be inferred as a string, but we want a character. Interesting. I didn't know character was a type. Var remaining distance float equals to 30. Okay. So 30 would be inferred as an int, but the variable should support decimal numbers for accuracy as the number decreases. So we didn't learn about floats yet. We've just done doubles. So a float can be either a double or an integer. So just something to be aware of. When you write your own type definition, okay, let's see. Struct so var make, it's going to be a string. What on earth? Var model is also going to be a string. And var year is going to be an int. No. Int. What int max? What are you talking about? Just an int. There we go. Okay. Let's continue. Required values. Whenever you define a constant or variable, you must either specify a type using a type annotation or assign it a value that the compiler can use to infer the type. Var x, this would result in an error. Even when you use a type annotation, your code cannot work with a constant or variable if you haven't yet assigned it a value. Var x, integer, print x, this would result in error, obviously because it doesn't know what x is yet. Okay, once the value is assigned, the constant or variable becomes available. So var x int, and then we tell x is equal to 10, and you tell it to print, and it'll print you the 10. Very cool. Okay, next. Alright, open and complete the exercises in Lab Constants and Variables Playground. And now we can do these quizzes here. Which of the following values would be best represented with a constant? Player name, player level, player score, player location. Player name, that's going to be a constant. Check answer? Alright, next. Which of the following would be best represented with a variable? Age. Alright, next. Which keyword is used to declare a constant? Let. All right. Which keyword is used to declare a variable? Var. Okay. Which of the following is not a reason for declaring most values as a constant? Which of the following is not? Keyword not. A reason for declaring most values as a constant. It's a best practice. The compiler can make special optimizations. It is safer. Developers can rely on a consistent value. Most values never change. This is not correct. All right. Using type inference, which of the following variables would be assigned a double type? Var, state, no. Country, no. These are both strings, and this is a int. This would be a double. All right. Which of the following code snippet compile? Which will the following code snippet compile, and why? Let number double equal to 3. Yes, because the compiler will assign the value 3.0 to number. Alrighty. Because we know that because doubles have a decimal, it would automatically add the .0 to it, since you're implying that you want this variable, this constant of number, to be a double. There. Oh wait, what happened? Check answer. We answered all the questions. What happened here? 6 out of 7 are correct. Which ones did we not get correct? We got all of them correct. I'll select more answers. I didn't realize there was more than one answer here. Which of the following would be best represented with a variable? The age can change. Why would the home address change? Why would the birthday change? Why would the name change? Or is this speaking of multiple different people? So the name, so all of these would change in that case. Why would a home address change? See, this doesn't make any sense, because a person's home address is a person's home address. There's no reason why their home address should change. So that would technically be a constant. A person's birthday is a person's birthday. Why would it change? And a person's name is a person's name. That shouldn't change either. So I think what the confusion here is that they're not making this clear. There has to be a revision of page 33, because if all of these can technically be variables, in the case that this is actually, they're referring to a code running from top to bottom, and then in a second instance running again. For instance, the way it did in the navigation example, where the starting point, or like the starting point is a constant, but it can also be a variable, because of when you run it the second time, a different person is going to put that information in. So this isn't really clear. Okay, so we'll let these be, but that might need some revision by Apple, because not a great question, or not a clear question anyways, but that's fair. Alrighty, let's go on to the next page. And now we're on operators, and we will continue with operators tomorrow. Thank you for watching, and I hope to see you tomorrow. Bye bye.